Okay. Good afternoon, guys. So we are going to continue with DC circuits. So I ask you to try deriving the equivalent resistor equation for series and parallel. Those who didn't try, those who are in middle of trying, take 5 minutes and try it. After trying, please go through these notes. Now the derivation is very basic, so I don't think there's nothing much to explain in the derivation. It's pretty straightforward, so go through it. It's all IGCSE. If you don't understand it, put up a message in the chat. And others like it, and I would come in video call. Now just a couple of things. This also you might have studied in IGCSE, but just to refresh. So if the two resistors are identical, which are in parallel, then the equivalent resistance will be half of it. So if you have R and R connected, the equivalent would be R by 2. And the same is true for any number. If you have three identical resistors connected in parallel, then R by 3. If you have 1000 identical resistors connected in parallel, it would be R by 1000. If you apply that equation 1 over R, and the other side 1 over R1 would become 1 over R, 1 over R2 also become 1 over R, 1 over R3 will also become 1 over R. So if you have even 100 resistors, that would be 100 times 1 over R. So if you have 100 resistors which are identical connected in parallel, resultant will be R by 100. Then now the combined resistance will be, for a parallel circuit, would be smaller than the smallest individual resistance. Why? One thing, you can just substitute random numbers and check it is the pattern, but the real why, if you want, you can search. And yeah, after doing that, you go to the book, try out this first example, suppose the video, and read the question. Figure 20.16. So calculate the equivalent resistance of the arrangement of resistors in figure 20.16. So this is figure 20.16. Then after doing that, check the answer given for the example. It is explained. Then try doing this 6 and 7. You can pause the video and do them. So figure 20.17 is this, and for question number 7, 20.18 is here. Okay, so assuming you have done that, let me try question number 6 and 7. So you have to calculate the equivalent resistance of the arrangement in figure 20.17. So in 20.17, you have a 4 ohm and a 2 ohm and then a 3 ohm. So if you try to calculate the equivalent resistance of the 4 ohm and 2 ohm, the parallel circuit, so you have a 3 ohm here, and you have a 4 ohm, and you have a 2 ohm. So first let me calculate it for the parallel. So 1 over R would be 1 over 4 plus 1 over 2. That would be 1 over R is equal to 4. So R is equal to 4 by 3. So the equivalent resistance for the parallel combination is 4 by 3. So once you have done that, you have 3 ohm and then you have 4 by 3 ohm in series. So the equivalent resistance would be 3 plus 4 by 3. That would be 13 by 3. That is 4.3 ohms. Okay, 4.3 ohms. Then the next question asks you to find for this circuit between the points A and B. Now don't be confused about the pattern. All you have to do is you have to figure out it is a parallel circuit actually that is given. So don't be confused about, don't be deceived by the appearance. So the same circuit here can be drawn like this. So it can be drawn. So this is your A. So on one side you have 20 ohm and a 10 ohm. So this is your A and this is your B. On the other route you have 100 ohms and 50 ohms. So if the question was given like this, you would have immediately done it, but that shape, giving it as a rectangle, might make you confused, but don't be deceived. So now this is easy. First you find the series. So you are basically having 30 ohms here and you're having 150 ohms here. So 1 over R is equal to 1 over 150 plus 1 over 30. 1 over 150 plus 5 over 150, that's going to be 6 over 150. So R would be 150 divided by 6, that is 25 ohms. Okay, good.